Imagine wheat in a field. The farmer fertilizes with plenty of nitrogen and the clouds bring rain, enough to last until harvest. The farmer comes along and harvests all the wheat and makes a big profit, enough to maintain his farm and feed his family. Imagine wheat in another field. The land falls into a drought. However, the field has enough nitrogen. But will the wheat make it to harvest? The farmer comes along and harvests all the wheat, but does not collect as much grain. Imagine wheat in a third field. It has enough water, but not enough nitrogen. When the farmer comes to harvest, half of the field is dead. Imagine wheat in a fourth field. It hasn't had any rainfall since it was planted. And, as if the wheat doesn't have enough trouble, it does not have enough nitrogen. Will this wheat even make it to harvest? Now, imagine one more field of wheat. It has enough water for the first 2 weeks of its life, but very little nitrogen. Then the rain clouds disappear. No one knows when they will be back. Then suddenly, they appear weeks later, but the downpour only lasts a minute. Then the clouds are gone. This cycle repeats again, but the next rainfall is lower. Up until now, there is a lot of research being done with drought or nutrient stress separately, like in fields 1 and 2. What we don't yet fully understand is how wheat responds to drought and nutrient stress when coupled together, like in fields 4 and 5. With my research, I want to look at how wheat responds to both water and nitrogen stress. Will wheat produce more roots, or will it produce more shoots? This is a healthy wheat. It is living under the perfect conditions, and so it produces large roots and shoots. This is a rather sad wheat, because it did not get enough water or enough nitrogen in its short life, like in field 4. To counteract this, it produces fewer and longer roots, going deeper to scavenge whilst maintaining shoots and grain yield. This wheat is even more unhappy. During its life, rainfall was very erratic and unpredictable, like in field 5. This and the lack of nitrogen resulted in a noticeably smaller plant. Smaller plants mean a smaller grain yield. So why is this research important? Climate change is changing our weather conditions, creating more erratic rainfall. And because nitrogen uptake is affected by water levels in the soil, less water means lower nitrogen uptake. Less water equals lower nitrogen uptake, equals smaller plants, equals lower grain yield. By doing more research in this area, we can create better crop management programs and models that can tell us how to maximize crop yield with minimum water and nitrogen. That's one small step for a farmer, one giant leap for agriculture.